Hello everyone, my name is Mohit and today we'll discuss the topic normalization and normal forms. The goal of normalization. So to avoid the data redundancy in the database, we use normalization. How to perform normalization? By converting the database into normal forms. So what are the benefits of normalization? So basically it reduces the complexities by reducing the anomalies in the database. Now, what are normal forms and normalization? Normalization is the process of minimizing redundancy from a relation or a set of relations. And normal forms are used to eliminate or reduce the redundancy in the database tables so as to reduce the complexity of the database. Redundancy in relation may cause insertion, deletion and updation anomalies. So it helps to minimize the redundancy in the relations. Now what is first NF? So basically, before going to that, there are most commonly used normal forms. So these are first is first normal form, second is second normal form, third is third normal form, and fourth is Boyce and Codd normal form, that is BCNF. Now first normal form. If a relation contains composite or multivalued attribute, it violates the rules of first normal form. And if if it is does not containing any composite or multivalued attribute, it satisfies the rules of first normal form. A relation is in first normal form if every attribute in that relation is single valued attribute, and the first NF database must contain atomic values. Now here we can see the example of first NF. In table number 1, we can see there is a database containing the student details with attributes such as student number, student name, student phone number, and student state and country. Here you can see there are two phone numbers mentioned of Ram here. So this violates the rules of first NF, and we will convert it into first NF by separating out those mobile numbers in separate entries. So now in table number 2, we can see that it is in first normal form and it satisfies the properties of first normal form. Now second normal form. To be in second normal form, a relation must be in first normal form and relation must not contain any partial dependency. A relation is in 2NF if it has no partial dependencies. Now what is partial dependency? If the proper subset of candidate key determines non-prime attribute, it is called as partial dependency. That is, no non-prime attribute is dependent on any proper subset of any candidate key of the table. Now what is non-prime attribute? Attributes which are not part of any candidate key are called non-prime attributes. So here we can see the example. Suppose a school wants to store the data of teachers and the subjects they teach. They create a table that looks like containing the teacher ID, subject and teacher's age. Since the teacher can teach more than one subject, the table can have multiple rows for the same teacher. Now here candidate key is teacher ID and subject, but the non-prime attribute is teacher age. The table is in first NF because each attribute has atomic value. However, it is not in 2NF because non-prime attribute teacher age is dependent on teacher ID alone, which is a proper subset of candidate key. This violates the rule of 2NF as the rule says no non-prime attribute is dependent on any other proper subset of any candidate key of the table. To make this comply with the 2NF, we can break it into two tables like first teacher details table which contains teacher ID and teacher age, and second is teacher subject table which contains teacher ID and subject. So now the table comply with the second normal form. Now third normal form. A relation is in third normal form if there is no transitive dependency for non-prime attributes as well as it is in second normal form. A relation is in 3NF if at least one of the following condition holds. In every non-trivial function dependency, that is X to Y. Here X is super key and Y is a prime attribute. Each element of Y is a part of candidate key. Here you can see an example. Suppose a company wants to store the complete address of each employee. They create a table named employee details that looks like uh, containing employee ID, employee name, employee zip code, employee state, employee city, and employee district. Now here the super keys are employee ID and employee name and employee ID, employee name, and employee zip code, and so on. Now candidate keys are employee ID, non-prime attribute. All attributes except employee ID are non-prime as they are not the part of any candidate key. Here employee state, employee city, employee district dependent on employee zip code and employee zip code is dependent on employee ID. That makes non-prime attribute employee state, employee city, and employee district transitively dependent on super key employee ID. This violates the rule of 3NF. To make this comply with the 3NF, we have to break the table into two tables to remove the transitive dependency. So here we will divide the table into two parts. First is employee table, which contains employee ID, employee name, and employee zip code. And the second one is employee zip table, which contains employee zip code, employee state, employee city, and employee district. So here we will remove the transitive dependency by this and make it a 3NF. Now Boyce code normal form BCNF. A relation R is in BCNF if R is in third normal form for every FD. LHS is a super key. A relation is in BCNF if in every non-trivial functional dependency X to Y, X is a super key. Sometimes BCNF is also called as 3.5 NF because it is the advanced version of 3 and third NF. And now we will understand this with an example. Suppose there is a company wherein employees work in more than one department. They store the data like employee ID, employee nationality, employee department, department type, and their department number of employee. Now here functional dependencies are in the table are employee ID to employee nationality, employee department to department type, and department number of the employee. Candidate key is employee ID and employee department. The table is not in BCNF as neither employee ID nor employee department alone are keys. To make the table comply with the BCNF, we will break the table into three different tables. First will be employee nationality table, which contains employee ID and employee nationality. And second table will be employee department table, which contains employee department, employee employee department, department type, and department number of the employee. The third table is employee department mapping table, which contains attribute employee ID, employee department. So here the functional dependencies are employee ID to employee nationality and employee department to department type and department number of employee. And the candidates for the first table, candidate keys for the first table are employee ID. Second for second table is employee department, and for the third table employee ID and employee department. So this is how this database is converted into BCNF, and as in both the functional dependencies left side part is a key. So this is now in a BCNF form. Thanks for watching.